Liftoff. Liftoff. 30 minutes. Now ready on.
Hello and welcome to AWS Made Easy episode number 106. Now, this is the show where we interview AWS guests, we talk about AWS, cost optimization, AI, and we answer your questions. My name is Stephen Barr.
Hi, everyone. I'm Rahul Subramaniam, and welcome to today's show. So, Stephen, what are we talking about today?
Well, there was a really neat article put out by a GitHub repository by Clare Liguori, and then Brooke Jamieson wrote a really neat blog post about it. It was about using step functions and serverless generative AI to really show how they can chain together a sequence of events, of actions, of thought. And this is what I really like about this blog post is it gives like real examples. Some people are wondering, what do I use AI for? And this is real examples. So we wanted to talk about this blog post. And yeah, that's going to be the main focus of the show today.
And talking about AI, just for the audience, we are still trying to get Bedrock Studio to work. We've made significant progress, but there's still been some issues in the way Bedrock Studio currently works. But we are working with AWS, and we'll keep you posted as soon as we can get that working. So we have a definitive guide for you. In the meantime, this particular article that we're just talking about is actually really cool, and I can't wait to dive right into it.
Absolutely. I'll do one quick mention first, and then we will dive into the article. The one thing I wanted to mention is the AWS goodies. Now, there's a bit of self-interest in here for a few reasons. So this is published by my dad, Jeff Barr, AWS. Now, he's publishing this a couple times a week, and they are kind of a survey of AWS-related content that's out there. They've got the Career Cloud Journeys book, Improving Price Performance Using AWS Graviton. It's really neat. And oh, look, we're there. So we made the AWS goodies list this year. There's lots of great stuff here. Have a look. There's lots of great content. CloudFormation, CloudTrail, Graviton, which we are big supporters of.
Correct.
We have lots of great Graviton-oriented finder fixers. Blog posts on 5 lessons learned in building generative AI applications with a workflow. So this is interesting. More about blog step functions, CDK integrations. We talked about that on our AI Friday last week with CDK Bedrock agents. So have a look at episode 105. That was our AI Friday last weekend for that. And this is also our we got a shout out. So that's pretty cool. That's our Bedrock agents CDK Lambda. And we put out our template repository to show you how to get started.
Correct.
So we've got this. Again, check out this from last week. So check out the AWS Goodies series published by Jeff. So that's a really neat one. We'll put the link in the description below. Just follow him on LinkedIn. All right, on to the main post. This is build serverless, scalable, generative AI apps with this GitHub repository. So we are covering an article about a GitHub repository. The article is written by Brooke, the GitHub repository by Clare Liguori, principal senior engineer at AWS.
Correct.
Well, what are you had some really cool thoughts on this one. What did you think about this?
Yeah, so let's just dive into it. Now, this article actually talks about some very interesting use cases where they have tried to chain a bunch of different prompts to perform something real or to perform a real task, right? And traditionally we've used solutions like LangChain to achieve this, but in this particular case, there's a really neat mechanism of using step functions to achieve the same results. And I think this is a very, very neat way of doing it. So as we go, why don't we go through some of the examples so that everyone gets a sense for what those tasks might look like, and then I'll chime in with some insights about where you should use this over places like LangChain, or what are the strengths and weaknesses of each of those systems.
So I guess they're starting with the simplest example that's not even a chain of generate a book summary. So this is one
Yep,
step, but they have to start from the simplest case and work their way outwards. This is a one sentence summary of Pride and Prejudice by Jane Austen. Okay, so
correct,
that's one. But then, okay, how would you want to template that? They're saying you could have a generate book summary template and then just provide the input of the book. So
correct.
here is basically doing the same thing, but now you've got a variable. Okay, here's where it gets into chaining.
Yep,
So this one says, how would you generate an advertisement for a book? So step one, generate book summary, and step two, generate book advertisement. So the idea is you have that template that you went from the first step, you put in a book. The
correct,
first invocation of the LLM could be summarize the book, and then the second one could be generate a book advertisement.
correct.
Now, the
Which
cool
takes
thing
the
about this,
summary as an input
mhm,
and then generates the advertisements based on the summary.
and so this could be two different models, right? The first one could be Claude, the next one could be Haiku. They could be, you could use Chat GPT, you can have totally
Correct,
different, whatever it is,
correct.
right? Or
In
even
fact,
different tunings of the
yeah.
same model.
In fact, if I were to take this one step further, the generate book advertisement could have a text component to it, and it could also have an image generation component to it, where you generate, backgrounds, or you generate some images to go with the advertisement. So you can actually break it up into multiple steps that could call completely different sets of models to achieve the outcome.
And hopefully soon you can make a little video of it with Sora. You could have
Yeah,
a soundtrack with Suno. So you're right. You could do a whole multimedia extravaganza
correct.
uh, to advertise Pride and Prejudice.
Exactly.
So why would you want to do this? Why wouldn't you just do this in one Python script, take the input of one and just call you can do variable substitutions with mustache and Python. Why would you want this additional complexity of step functions?
Okay. So personally, I actually think that step functions simplifies things because you have the visual editor in step function, that it makes life easier. So, from that standpoint, I don't really think it complexifies things. That said, you already have very mature tools like LangChain that help you chain a bunch of these simple steps together. And that's kind of what LangChain was designed to do. However, I think the strength of this particular pattern of using step functions lies in the fact that number one, step functions can actually execute over a period of days. So anytime you have a long process that might have steps where you have to wait for things, you have to wait for really long periods of time for asynchronous work to happen as part of your flow, you can actually leverage step functions to execute those. And the decision making steps or input generation or input processing steps could be LLM based in a much larger, much more complicated process. So if you have a step function already in place that does something like an entire order processing system, right? And let's say, as part of that order processing system, you wanted to generate a little limerick for a very specific customer, or for every customer, just customize a limerick for them as part of what you ship to them. This would be an amazing way to do it, where you have an entire order processing flow that's already in step functions, and then just add one new step in there that creates a customized message or a customized, thank you note for that customer, and it prints it along with it and ships it. So there's some very interesting use cases, very interesting ways in which you can use this. And like I said, you can have inputs as part of the step function flow that are human inputs or external system inputs that get triggered to take the steps forward. So I think that's a real advantage of this. With things like LangChain, you wouldn't really be able to run these long running processes, because at the end of the day, it's Python code, and unless you've really made sure everything's going to run beautifully in multi-threaded environments, like you have tens of thousands of threads running in parallel, it's going to probably fail or crash somewhere down the line. Exception is a
So,
great way of getting that scale in parallel. You have 10,000 users coming in, each flow is going to run over 2 days. That's totally fine.
so you're saying with LangChain, there's no great way to save that intermediate state because it's just running with the Python environment. And so if you have
Exactly.
one of the steps is insert the limerick into the box and take a picture to make sure we packed the box correctly, that might only happen. That's going to happen in batches.
Correct.
right? There's not someone sitting there hitting refresh, waiting for this to
Correct.
happen. That's happening in batches. And so you can have a bunch of partially completed step functions much more easily than partially completed LangChain chains without
Correct.
writing a whole bunch of infrastructure to save the state, to pause the state, like I said, make sure it's robust to a computer going down, getting
Correct.
rebooted, one of the threads crashing and not breaking the whole thing.
Correct.
Okay.
So that's incredibly useful. There's one other aspect that I would like to mention, which is all about memory. Now, by default, the way the step function mechanism is set up, you would typically take the output of the previous step, and that would go in as the input to the next one. And that's the typical model of operation, right?
Mhm.
So memory is constrained to the previous step, but you can overcome that by having external memory. So, for example, you could actually have a thread that is saved somewhere where you have the entire chain of conversation, if that is what is relevant to making decisions, or you could store the multiple responses from multiple steps in the chain somewhere else with the step function ID or the invocation ID, and you could solve that problem that way. Um,
Sounds like a good use for DynamoDB.
you could use that. I mean, you could have any number of different mechanisms to store it. You can store it with DynamoDB. The problem with DynamoDB, however, is that each record can only be 400K. So be careful about that. Sometimes some of the generated stuff could actually be much, much larger. Sometimes the memory that you need might actually happen to be a RAG or a vector database that you need to
There you go.
query over and over again. Or you might have a knowledge graph that you create, a property graph. You can do that with Neptune. You can actually create a property graph, which is your knowledge graph, which you need to query for insights that were generated in previous steps. So there are multiple different ways in which memory can be implemented. A lot of that comes out of the box with LangChain, where you can set up that memory aspect quite easily. However, with this, you will have to set it up as an external entity. It's not hard. You could probably use LangChain to do the same thing and just have LangChain as a component that you use or the memory as a component. But just something to remember as you're trying to create these long drawn, step function implementations of chains.
All right. So to summarize, up until this point, we only have a two-step chain, but already comparing it to, so I think in the easiest case, just writing it in Python and feeding one right into the other,
Right.
is that you can't pause.
Correct.
And then the same thing with LangChain, you you can't really pause and wait for human input. And although we're not doing that yet, it's very quick to see that that's going to be on the table, or you'd want
Yes.
to make it on the table.
Correct.
Well, let's have a look at the next. Parallel chains. All right. So what is
Yeah.
this?
So this one is also very interesting. So with step functions, as you're aware, you can actually run multiple different tasks in parallel and then combine the chain back or combine their entire flow back to a particular node. And you can wait till all the different threads have processed. And that's a really nifty capability of step functions that you don't get easily anywhere else.
I like this example of generate book summary and generate books target audience. And we
Yep.
saw that on Friday. One of the things that we tried to do with the Bedrock agents, we said, generate this list of steps and update the
Correct.
task. And we remember it did the first thing, but it didn't do the second thing.
Correct.
And LLMs, they're good at doing one thing. That's why you want to do the step by step.
Correct.
And so I really like this idea of separating it out into two very distinct questions that, again, could be pulling in different sets of data, right? If you are generate the book's
Exactly.
target audience, well, you may be interested. If you are a publisher, you may have very specific demographics. Maybe you're the dental office waiting room demographic. I don't know. I'm sure there's plenty of different demographics that you're thinking about if you are a book publisher and you want to make sure you summarize it in a way that works for your audience. So I like the
Correct.
idea of separating this into two different questions, might have two different models, two different rags associated with them, whatever
Correct.
the case may be.
Exactly. And then the nice thing about step functions is also that you can create very complicated flow scenarios. For example, you can have retries or you can go back to a previous step if something didn't quite work out the way you wanted it. You could reset the flows. You could do all kinds of amazing stuff that you would be limited to perform with something like LangChain. This is an entire workflow management solution that you plug into pretty neatly.
And that's one of those things. What did Einstein say? Make it as simple as possible, but no simpler. And so,
Yes,
if you wanted to try and make it simpler than this, you'd end up rewriting all of this stuff anyway.
correct.
Because as the problem scope increases, you're going to want all of these mechanisms.
Yeah,
And better to use AWS's step functions. They've already been tried and true, rather than try and implement a half-baked version on your own.
correct. And the beauty of this is that you could actually scale your solution really, really well. So, for example, if all of a sudden you had, let's say 1,000 users want to use your system or 1,000 different invocations all at the same time, it would be really hard to build a solution with LangChain to scale that up, to do that all to do 1,000 parallel sessions, right? But as step functions, you can literally wait till the user count, goes down to a certain point before which you trigger the next step to say, okay, I want to now execute my chain. If you have API limitations, if that's not the case, you can even have, a binary backoffs. And it doesn't matter if it was 1,000 or if it was 1,000,000. The step function part of it would scale just as well. And you could run all of them completely independent of each other without having to worry about which box you're going to do, how is it going to scale, how is state maintained. You don't have to worry about any of that stuff.
One thing I was thinking about with these parallel tasks, to say if you wanted to generate book summary, what if you generated 10 different book summaries with different top Ks and different temperatures, and then you had a human interface step, say you had a little focus group, and say,
Yeah.
which is the best book summary? And you had someone read the 10 different ones, pick them, and then you write the advertisement. That
Yeah.
would be kind of a fun way to do it.
Great. That's actually a really good example of where step functions would be incredibly useful. If you want a human in the loop kind of system, then having step functions be the implementation makes a lot of sense.
All right, well, let's go on to the next usage, conditions. Okay, so this
Yeah.
is another, like a classifier. So this one is decide if the input is a book.
Yeah.
And sometimes we always see with data, sometimes it gets dirty, right? Sometimes you're going to see Jane Austen the movie, or Pride and Prejudice the movie, or some parody take of it. You don't want to automatically advertise.
Yeah.
So is the input a book, and is it the original book? Would be maybe another question.
Right.
So what how complicated can these conditions get?
Oh, you can literally have a lambda that returns a true or false as your decision step. So you could make it as complicated as you really need it to be to solve whatever real world problem you're working on. So it's not trivial. You do have simple trivial operators if you want, but you could literally just replace it with a lambda invocation that actually decides what your decision making process is.
Some tools just find AWS cost savings and make you do all the work. Visualizing cost opportunities is great, but that's not enough. CloudFix, on the other hand, actually delivers those savings for you. And you don't need to worry because CloudFix fixers are AWS recommended and easy to use. It's the only tool that fixes cost savings opportunities and doesn't just find them. It's the easiest way to save money on AWS. It's all 100% automatic and risk-free. And the best part is that it works nonstop. See for yourself. Click on the button to get a free demonstration of CloudFix and stop overspending on AWS today.
So I'll give you another really neat example of this where this makes a lot of sense. So let's say you had, let's say your financial management system was something complicated like NetSuite, okay? Or let's take a CRM example because that might be even easier. So everyone is familiar with CRMs. Let's say you were using something like Salesforce. Now within Salesforce, let's say every time a customer comes to your site and tries out a few, does some interactions on your website, and let's say they leave you with feedback on the website, you can immediately take that into an LLM, go through the entire process, send them an email, send them a customized message, immediately responding back to them, saying you understand it and here's the decision you're going to take. You can file tickets on behalf of the customer. You can do so many amazing things using the step functions, talk to different systems, incorporate all the solutions that you need or resolution mechanisms that you need to have within the step function mechanism, and respond back to the customer in seconds rather than take a while. So step functions becomes really easy to do all of that.
And thinking about from our cost-based lens, I really like this framework as a chance to use the cheapest model for the job, right? Because some of these
Correct.
classifier questions are great for Haiku, and maybe if you have a node with 50 steps, maybe 3 of them need Opus and the other ones don't. So this is a great way to mix
Couldn't agree more.
models, I guess, independently of each other.
Correct.
I guess another plug for Haiku. I always kind of start with Sonnet, and then I'm always surprised that Haiku almost always does nearly as good. I have to remember it's 1/10 the price.
Yeah. So I find that I either use Haiku as default, or I would go to Opus. I have not found a unique use case for Sonnet yet.
I guess that's a good point, where it's right in the middle. All right.
Yeah.
Now this one is mapping. So maps states allow iterating over a collection of inputs, processing each one with a prompt to generate an array of inputs. So just like you have map reduce or just the map operator in various functional language, this is the for loop of step functions. So what is
Correct.
the loop through novels? So this is if you wanted to reuse the same process, but for a variety of novels. Let's see what other. Okay, so here's where they're talking about. Oh, here we go. So prompts can be chained with interactions with other AWS services, like retrieving data from S3 or invoking Lambda functions. So this is cool. Okay, you can get an SNS topic of this. So where do you see these use cases being in? And again, how would you compare this and contrast this with integrating it into LangChain?
Got it. So I think 2 or 3 examples come to mind immediately. SNS topics. So whenever an event is triggered somewhere, let's say somebody uploaded an object into an S3 bucket, that could immediately trigger one of these step functions, and that step functions analyzes the data that's in that S3 object that just got dumped in. That's a perfect case. Let's say you put in a video, you put in an image into an S3 bucket, it does the analysis, and then takes appropriate action, right? That's one example. The other one that I was just talking about, for example, CRMs. If you have to, do a bunch of analysis and immediately get back to the customer via email, you could use a service like SES, which is beautifully integrated into step functions. And that could send out an email back to the customer to say, hey, I analyzed your stuff. Here's the response. You can be cordial. You can truly understand what the customer wants very, very quickly and respond in a very, very personalized or customized manner.
What I really like with SNS, I remember when I was building up some automation and I'd want to send a message to a Slack channel, I'd always have to Google, okay, how do you send a Slack message from Python? And there's 1,000 different tutorials. And finally, I just had to put up an SNS topic that whenever I send a message, it forwards it to a Slack channel. And so whenever I want to talk to Slack, I know I can just send an SNS message to this one channel, and it will show up in my Slack bots Slack window, and I can see it. And I never have had to look up how do you send a message to Slack ever again, because I have that one Slack that calls a Lambda function that I couldn't even find the source for if I wanted to. But that's done. And I like that. You can do it with email. You can do it with SNS. You can do that with any number of external systems.
Exactly. You can even use SQS for that matter. So you could have a queue that just keeps accumulating a whole lot of requests, and then you can have step function as a processor for the queue.
All right. Well, here's where it gets cyclic for the first time. So this is what we're seeing. Validate, output, and reprompt. If a model's response fails validation, it can be reprompted to fix its output with error handling capabilities in step functions. I think this is particularly true of Claude's. They can take a little coaxing to get to say, the JSON and nothing but the JSON. You have to start with a
Correct.
curly bracket, end with the other curly bracket. So, and
Correct.
sometimes occasionally it'll say, here is the JSON you requested.
Correct. You have to be very explicit with the instructions to produce only JSON and nothing else.
So let's see. So what would this be? Okay, and so you can have a counter in your step function. So I guess this would have a counter of saying how many times on this invocation have you been through this particular node?
Correct.
So how have you seen these? How would you use the handle parsing error?
So you would basically take the parsing error that came up, and you would send it back as part of your QC or your error message. You would send it back to a previous step where you not only have the original prompts, but you also have a feedback loop that says, please make sure that this error does not show up, or make sure that whatever code you generate, or make sure whatever JSON you generate takes into account the possibility of this error. And that's how the LLMs get better at fixing the things that they got wrong.
Neat.
And then you could also have a step counter, so you can say try 5 times and then just give up. So you could have those kind of mechanisms.
And push the failures to some other SQSQ.
Exactly.
All right, here's what you brought up at the very beginning, the wait for human input. So here they have decide if input was a book. Is it a book? State machines can pause execution and wait for human input using task tokens, enabling interactive workflows. So where's the human input? Is this the decide if input was a book step? This could actually be done by a human.
Correct. Or even, is this a book? Is it a book, or is it something else? So you can decide that by a human, or an LLM could do it. So any of these, you could even decide, the human input could decide which path to take in those scenarios.
Okay.
And so that's definitely, possible as well.
Let's have a look at this practical example. So here's the architecture that they are showing. Let's see. We've got a Streamlit application. We've got a couple of demos, and then, of course, powered by Amazon Bedrock. So pitch a movie idea, write a story, write a blog post, plan a trip, and authenticated with Cognito. That's pretty cool.
Yeah.
Okay, so let's look at the write a blog post one. So in the workflow, they're saying, here's the steps that they have. Write a summary, describe the plot, analyze key themes, analyze writing style, and then write a blog post. So the example they're giving is a novel, and they are writing a 5-paragraph blog post on this. So again, you probably could type in write a blog post about Pride and Prejudice right into ChatGPT, but it's going to be very, what do you call it? It'll have that, what's the right word? You'd know it was a ChatGPT output, right? It'll probably use the word, let's delve into Jane Austen, right? So, okay. Should we have a look at the, okay, so let's have a look more deeply into this one here. For an example blog post.
The repo is actually very, very simple and neat. I really love the way this repo has been put together. You should take a look at the CDK. Just go up to the CDK. No, right on the top, there is the source code. Yeah, there you go. Yeah, just go back to the CDK for this. It's really simple.
Okay, I see. So we're in the write a blog post.
Let me see if I can bring this up quickly on my end.
Oh, here we go. Blog post stack.py.
Yeah,
okay.
That's the one.
Let's zoom in on this.
There you go.
Blog post stack.
Correct.
Okay, so they're using get anthropic Claude, invoke chain.
Correct. And that's the JSON definition of your step functions.
the step function.json path, that format,
Yep.
and then describe the plot here. So using Claude, again, write a paragraph describing the plot of the book.
Correct.
Neat. Okay. So this is the chain together,
Correct.
and then select final answer. So that, oh, I see. So here's how they're putting it together. So there's a
That's
plot,
the state machine at the end.
and so in this case, it's just very sequential.
Yeah.
Wow, that's very, very clean, concise, easy to follow code. I mean, I haven't used step functions
Exactly.
very much. I don't think, so that's really easy to follow.
Yeah. This is really, really simple. So if someone hasn't tried this yet, please do. It's really neat, makes life really simple.
I'm going to star this.
Yeah, this Trevor definitely deserves a star. It's a great starting point for whatever you want to build. We'd love to hear from you about your ideas of how you want to leverage step functions and LLMs changed together to produce some amazing stuff.
Let's look at this movie idea. AI acts as a screenwriter, pitching movie ideas to the human user acting as a movie producer. Okay, so this is human in the loop. Let's have a look
Yeah.
at this.
So if you look at the chain in this one, you will find the green light step. So that is a human decision.
So let's see how they implemented this.
Just search for
Green light.
green light.
Step 3. Let the human user decide whether to greenlight the movie or not. So what are they doing? Seek user input, duration 5 seconds. So what are they actually doing here?
It just gives you an input box and you say yes or no.
And then so the Streamlit is actually serving the box.
Correct.
Wow. Okay. Okay. So this Lambda function, what is it handing back? Handing over? It's handing over the actual box.
I think it's just the choice.
sfn.choice. Okay, I'm going to understand how step function choice works. Okay.
So it's just like, think of it as a decision box. It's a yes, no. And when each one of those when and otherwise are basically different outcomes out of that decision box.
So let's have a look at the Streamlit code. Is this the UI? No.
No, this
Okay,
is not
so this is the
UI,
stack.
but again,
Let's go over to the web app.
Yeah, that's the one.
Pages.
Home.py should have it.
Well, I think it will be the movie pitch.
Movie pitch.
Okay, so let's see where the green light, how that works.
So it's just a choice.
Oh, okay. So
if the response is green light is yes or no, it presents that output. There must be an input as well somewhere.
If there's a pending movie pitch, ask the user whether they want to greenlight the movie or not.
Yeah.
Oh, okay. So movie session state execution status paused.
And then there's a form, and then you're basically writing that back to session state. If yes, form.submit button, yes, greenlight the movie. No, try again. And then it basically does
continue state machine. So what is continue state machine?
So continue state machine, it just sends the data back to. You see the continue execution step function
right here.
So the step function.
Wow. Okay.
So simple.
Neat. Okay, so they continue state machine with task result. Task result is just going to be the yes or no.
Correct.
Cool. Wow. Okay, this is really good. This is also really good Streamlit.
Yeah.
I have a few Streamlit processes or projects in the queue. I'm definitely going to use this. as an example of how to write much better Streamlit. Yeah, okay. So it's form, submit the button.
If you are a fan of Streamlit, there is one
Here we go.
there's one YouTuber that I would really recommend everyone check out. Give me 1 second.
And so here's what it's sending back: movie description, movie pitch, and then yes or no. That's so simple. And then
Yeah.
continue state machine result. And so it's just going to look for a yes or no on the other side, right? If we go to the stacks, movie pitch stack.
Yeah.
There's going to be a yes in there.
There you
somewhere.
go, Bedrock, you got Lambda.
Yeah, there.
There.
That's cool. Okay.
That's your choices. Take a look at, I just shared with you a very cool YouTube channel. I love this particular YouTuber who has done an amazing job of very quickly and very easily defining all the Streamlit best practices. If you can just bring that up on the screen. Yeah, so that's Fanilo Andriana Solo. I hope I pronounced that correctly, but the content is absolutely fabulous. I'm a huge fan of. I learned all my Streamlit watching a bunch of these videos.
Oh, cool. All right. I definitely need to see this. So Streamlit, I am not a great front-end developer, so Streamlit is my best choice for getting anything out of a CLI tool. My front end is argparse. So this is any choice of getting something into a browser,
Correct.
it is going to be Streamlit. I'm going to give this a try.
Yeah, check it out. And yeah, let us know what amazing use cases you create with step functions and your LLMs. Can't wait to see.
All right. He has got one more subscriber. And speaking of subscribers, I wanted to show a pretty cool thing. I put this on in this window. Check this out. We just hit 800.
Awesome.
So
You're
thank
getting
you
there
all
slowly.
for subscribing. It's kind of cool. I'm happy with 800. That's a real honor to have you being subscribed, have you watching the show. So thank you, and tell your friends, share our content if you find it worthwhile.
Great. I can't wait for us to hit 1,000, and then we will make a little celebration of that. We'll do another live show and a live performance of trying to solve a hard problem with LLMs and AWS.
Yeah, absolutely. Well, this is a really cool. Wow. So look at the details. Generate character story arc. Now, this is where you could really have different LLMs go on in different directions.
Correct.
Right? Because sometimes when LLMs are generating stories, they're almost too simplistic. Right? The arcs are a little bit stereotypical.
Right.
Whereas you can say, here's one character, and this character is going to be a villain, and you can generate their own story arc, and this character is going to be the hero, right?
Correct.
And then you can have something else that merges them, generate the full story, where that merging API has to make the components fit together, right? It's not being given a license to change the story. Okay,
Correct.
I'm really happy about this. This is a really cool post. Okay, last one. They are planning a trip, suggest hotels, suggest restaurants, suggest activities, create an itinerary. That's really good because the itinerary part has to take all of these things as given.
Correct.
Right. So if you said, give me a hotel, a restaurant, an activity, and create an itinerary all at once,
Correct.
it might not get all of your preferences for each one of those things.
Exactly.
And it'll start. Once you try to pin down one thing, it'll forget, and it will go. You'll say, no, I really want to have a vegetarian meal by the sea, and it'll put you the barbecue by the sea, and then you'll try and pin it down. You have to fight it. So this is really cool. You can create an itinerary with multiple components. Okay. Wow, this is great. All right, so check out this repository. This is really good ideas, really good code. And thanks, Brooke, for summarizing this. It really highlighted Claire's work and, of course, your own work for putting this all together. This is really cool. And Rahul, thanks for
Amazing.
the reference for the Streamlit guy.
My pleasure.
Vanilla. All right.
Awesome.
Well,
Thanks, everyone.
Yeah, it's been a great
Cheers,
episode,
man.
and we will see you for an AI Friday with George Costanza, with Bedrock Agents, maybe even in Bedrock Studio.
Sounds good. See you all soon.
All right.
Thank you, everyone.
Bye, everyone.
Bye.